Hello, my name is Benedict, and I'll be bringing you some videos. I'll be bringing some videos your way. I'm here to see how I can help simplify complex chemistry terms, especially um, the graduate level. Yeah, especially on the graduate level, from 100 level to 500 level in chemistry. And today I want to give a brief introduction about Chem 101. Chem 101 is general chemistry, and I have some listed content, some course content at the course of subsequently on this very channel. I will be talking about most related things on this content on general chemistry. One of these is atoms. We'll be talking about atoms, molecules, elements, compounds, and chemical reactions. And then we have modern electronic theory of atoms. We'll see how the whole physical structure and electronic look of atoms right from the beginning. The beginning, what I mean by right from the beginning, is right from the very idea of what brought about atoms, the time of the Greek philosophers, down to the very time we are today. We see some of this advancement, some of this experiments, some of this scientific proof that all contributions per se that have been achieved, you know, at the cost of time. And then we have electronic configuration. Yes, we'll be talking about electronic configuration. We'll be talking about the build-up of electrons in atoms. We'll be talking about arrangement of these electrons in an atom. Talking about certain principles and rules that actually allows us to understand and to view clearly what happens with these electrons in atoms. And then also we talk about periodicity and building up of the periodic table. What comes about that, the periodic table, the very reason and the properties, the structure, the makeup, the trends, so many of this. That's the periodicity. We'll be talking about this thing. And then also hybridization, yes, the blending of atomic orbitals. We're looking at some of the blending and then how does it help us to actually understand some shapes of simple molecules. And then we'll be talking about valence forces and then structure of solids. For now, these are the very basic content. With time, I will review several other contents that we'll be doing. So today we said we'll be talking about general chemistry, Chem 101, general chemistry. So, like I said, we are going to start with the course content, atoms, molecules, elements. But before I go into this, let me try to see how I can give us a preview on what chemistry is about. Then I move one step at a time. The chemistry has to do with the study on transformation of matter. And the study of matter includes the study of the composition, the structure, and also trying to understand what this matter is made up of. That is the bond, the forces that hold this matter together. Yes, just for an example, if I intend to take a study on maybe water molecules, just for instance, water, I would love to understand if water really is the matter, right? Yes, it is. And then what is this structural composition, the physical structure, the composition? What is this water molecule made up of? And why does it appear the way it is? Because without this, there will be no way we can understand the chemistry behind water. So, chemistry has to do with the study of matter. Yes, anything that is of mass and can occupy space is a good thing to study. Okay, so before then, we have to establish that there is something that is most common to matter. Because if we're going to talk about the study of matter, then definitely there is a focal point there is a particular significant, uh, 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 should I say, a significant point or a significant term that we may not be able to escape while talking about matter. And this is some of the things that makes up this matter. Matter is made up of some of these components, and one of them is the atom. So I know we've heard a lot about atom. Atom, yes, atom came from the word atomos, which is a Greek word for indivisible. Yes, yes, a trace of the ideas that were established from the very beginning. Atoms were just, hypothetically, or like they were hypotheses that were made. There were no confirmed information or backup to what an atom really was. It was just an hypothesis, an intelligent guess, or an idea. Okay, rather, I'll prefer to say it was an idea that emanated from the early days. Greek philosophers, I think, around the 5th century. We'll be talking about that also. But for now, I want to focus on the definition of an atom. An atom is the smallest unit. Yes, it's the smallest unit of an element. And this smallest unit of an element tends to retain the chemical or the characteristic of that element. So what it means is majority of atoms truly they look different to other atoms or other elements. No doubt about that. Yes, it's true. Although these are some of the postulates we'll be discussing when John Dalton, I think in the early 19th century, when he was able to discover some forces that helped us to unravel a lot of secrets about atoms. So that is an atom. We said first of all, an atom. We're able to look at what an atom is. We said an atom is the smallest unit of an element and still retain chemical characteristic. What it means is it could actually take part in a chemical reaction. It retains the characteristics of the element. So what is a molecule? What is a molecule? And in the aspect of atoms, lest I forget, all elements are made up of atoms. Yes, all elements are made up of atoms. It is actually the key room to what the behavior of matter is because the combination of this or the separation of this atoms is what results to all chemical change. This statement is actually one of the pursuits of John Dalton. So we'll be talking about some of the things and seeing the importance of atoms when it comes to the discussion of matter because matter is indeed of relevance when it comes to chemistry. So the next point is molecule. What is a molecule? What is a molecule? How or what are molecules? Or how do you define a molecule? Okay, a molecule is um, the simplest or the smallest unit of a substance which has a separate existence and can actually take part in chemical reaction. What do we mean by separate or the simplest unit of a substance? Okay, since I started using water, let's proceed with that. Let me use water as an example. Okay, let's say I have a glass of water, and let's assume each of these dotted points are a flow. Now, that statement means I can have a bucket of water. I can have a glass of water. What this is saying is that this bucket or cup of water in it contains a reasonable amount of water molecules. What it means is that there are hundreds and thousands of water molecules held together by intermolecular forces or by secondary bond forces, which we'll be discussing. Also, we include that in the content when we come to talk about chemical bonding and then talk about primary and secondary bond forces. We'll discuss that in detail. But in water, each of the water molecules is held by the intermolecular forces by hydrogen bonding, which results as the affinity of hydrogen to electronegative atoms, especially oxygen, which is actually involved in the makeup of water. So what we're saying here is the simplest unit out of the hundreds and thousands of water molecules that is together that gives us what we call a bucket of water, a glass of water. The simplest of it is a single, just like taking one out of a bunch. So this shows us what a molecule is. So a molecule is the simplest form, is like the list of the units you can get in the overall. Because water we have water is actually one of the very vast matter. We have, I think, almost, if I'm not mistaken, more than or over 70% of the Earth's surface is covered with water. So this is to tell you that yes, this molecule of water, the simplest unit of it is just as one. And as we go on, we would understand that yes, there is importance in understanding that yes, this is a molecule because certain reactions require a certain amount of molecules of substances, and of which you don't take note of those amount of substances. It results to changes in results, especially when you're talking about chemical reactions. So we'll talk about that also, chemical reactions. So that is a molecule. So a molecule has a separate existence and can take part in a chemical reaction. So what is a compound? Okay, before I go into compound, I think we have elements. What are elements? We said something about an atom being the smallest unit of an element. And I wanted to establish also, we have some time agree with the definition of atom being indivisible. So in our subsequent video, we establish reasons why there is modification in such ideology or in such idea or process. So what is an element? What is an element? An element is a pure substance which cannot be split in or split by an ordinary chemical reaction or chemical process rather. Yes, it is a pure substance which cannot be splitted or cannot be split into simpler units in a chemical process. So what we mean by split into simpler units is when we say chemical process also, we mean when it involves this element. For instance, let me give you one example. I have sodium. Sodium is a group 1 element. So sodium as an element consists of atoms of its kind. Okay, so whatever chemical process involved here do not change who sodium is. Do not, transform sodium to something else. Whatever chemical process initiated there, do not, break it down to anything beyond that. We're not talking about we're not talking on size. We're making reference to transformation because we said something about chemistry dealing with the study of matter and transformation. What it means by transformation in chemistry means one thing can be made to be another. Okay? Yes, a very good example is like the chemical reaction. You can say yes, a chemical reaction is a transformative process. Yes, because reactants are transformed to what? The product, and in transformation, it's mostly related with breakage of bonds and all of that. So we'll talk about that. So that is it about an element. So we have elements in the periodic table. Yes, the periodic table is like the warehouse. Yes, permit me to use that. It's like the warehouse, the store where you can find virtually all elements in chemistry. They are very important. So the periodic table is a key manual. Yes, the periodic table is a key manual of which contains elements in chemistry, elements of importance. So I think we'll also look at that when we get to periodicity and the building of the periodic table, where we discuss about individuals who have contributed in the periodic table, people like Mendeleev, you know, Lavoisier, so many others of them. So what we're here is to discuss the basic foundational terms or terminologies that are required for you to understand, because in every build-up of a course content, there are terminologies, there are, you know, certain terms we need to understand before we move further. They're establishing our foundations and strength to move on in this course. So we just said something about elements, and aside from just having to see them in the periodic table, the idea of an atom, which is some of the discussion in the subsequent modern electronic theory of an atom, will reveal to us a lot, and the reasons why certain elements are arranged in the periodic table as they are, which is what informs the modern periodic law, yes, which is basically on the atomic number of elements. That is, elements are arranged based on that is the physical and chemical properties of elements are periodic functions of their atomic number. And atomic number is informed by the numbers of electrons in an atom. So you can see we have all of these build-up, and then we look at some of the basic things. Also, the constituents of atoms, the different particles that are also the basic makeup of atoms. So elements are made up of atoms. You can see how we're building it up. So what about a compound? Yes, a compound is also a pure substance, but in this case, a compound can be splitted. Yes, a compound can be splitted by ordinary chemical process. What I mean by splitted, a compound, in another word, you can say the compound is the combination of two or more elements. Yes, it's a combination of two or more elements. Yes, chemically, through chemical process. What I mean by through chemical process, there is high tendency for you to have a situation where, like the mixtures, for instance, mixtures are joined together or are combined together due to, physical means. So they are physically joined together. And that is why the ideology behind its separation is based on physical means, evaporation, distillation, crystallization, sublimation, a lot of the separation techniques or methods you can mention. So in the case of a compound are yes, chemically joined together. Yes, combination of two or more atoms that are chemically joined together. Or in another word, just like we said, in the aspect of splitting, they can be splitted by ordinary chemical process. What I mean by this is, take for instance, I have okay, examples of this element. We didn't make mention of them. We said that they're in the periodic table. You can name them sodium, so many of them from 1 to 118, 119, as much as you can name them. Example of molecules, we can refer to water, molecules, atoms of, and so what about our next point, which is compound? We've established that a compound can be splitted. Yes, let's say the compound, okay? The compound, okay? So many of them. You can name as much as you can, Why we call them compounds is because two or more elements are joined together or combined together to form a compound. So, and they're chemically joined together. What we mean by chemically joined together is that we are going to establish subsequently that an atom consists of the particles, like I said, the constituent of an atom. And one of the very key important particles, although all the particles are very important, but all what I'm saying is what informs, if you remember, if you can recall, from my recent definition of chemistry, I said chemistry, aside from studying the composition and the structure of matter, it also includes trying to understand the forces that hold this matter together. So you can see that what we mean by forces that hold this matter is that the atom is the reason behind all combination of separation. And one of the very key particles found in an atom that allows us the study of everything that exists. So long it exists, it does have a force holding it. It does have a bond. Its existence, why we can see this in existence, why our eyes can have a sight of it, is because, there are certain forces holding matter, that particular matter together. And that force is no other force than the interaction, that is, the behavior, the relationship between electrons of different atoms of energy. So what it means is before this became a compound, it means this element came together. And this element coming together, it means that the atoms of this element were involved in chemical process, in chemical